All right. So talking about writing an equation of a line. And key word there, obviously, is what is the best method in terms of going about solving that question. So first thing I want to do is just give you something that happens on the AP exam. They'll ask you the same thing, write an equation of a line, and they might use something basic here, nothing too difficult. Say f of x equals l of x at, let's say, x equals 2. So therefore, you have f prime of x, 1 over x. Therefore, your point, f of 2, would be ln of 2. So your point 2 ln of 2. And your slope, or f prime of 2, would be 1/2. Now, you could use a form, say y equals mx plus b. So to do that, you would have to plug in your y value. You have ln of 2, your slope 1/2, your x of 2 plus b. Therefore, your b would be ln of 2 minus 1. Therefore, your equation then, plugging everything back in, you have y equals 1/2 x plus, now your b value, ln of 2 minus 1. Now, you can see there took quite a steps here, but remember the question is just write an equation of a line. So instead of doing that, I could just came back down here and use the equation and just say y minus ln of 2 equals 1/2 x minus 2, and I'm done because I answered the question. So I bypassed all this stuff and finished. And they do accept that because I answered the question. So I want you to just kind of think about that as we progress here. How sometimes using an equation can be speeded up later on. All right, so let's start off with the foundation here. So we got slope, which is the foundation, and actually this is a slope equation. And again, I want to keyword there, equation. You have m equals y2 minus y1 over x2 minus x1. And again, the equation, the foundation of calculus. So if we take this equation and clear the fraction, then we get the point slope. Again, the word equation still appears. And we have y2 minus y1 equals m x2 minus x1. Okay. Now, from that, then you get different forms. But let's look at this, start off with terms of looking at different notation on this. So again, some of the things that happen later on, they might write this as y minus f of a equals f prime of a, times x minus a. I'm going to come over here so I have more room. Now you could also, so there's still the equations here, just the notation has changed. Now if I move this over, and I have then y equals f of a plus f prime of a of x minus a, or you could even, which they have done this several times on the AP exam, or I can move this piece behind it, and you have prime of a of x minus a plus f of a. Now if you notice, actually this one here would probably be a better one to look at. This is now the vertex form. Okay. Which is what we've been doing, graphing all the other functions like x squared, square root of x, absolute value of x. So we'll come back to that here in a little bit. I want to keep carrying this forward here. So if I keep taking this piece here, the next part would be, like, say, a Taylor series. Going back to this one here. So a Taylor series of, let's say, n terms would be, let's say, f of a plus f prime of a, x minus a. But then you keep going here, you have 1 factorial, and you go f double prime of a, x minus a over 2 factorial, and then f triple prime of a, x minus a, oh, that's cubed, that's squared, and 3 factorial, and you can keep on going. And basically what you're doing is taking your tangent lines and you're bending them and fitting around different functions. So anything that's not a polynomial, we create a polynomial using the Taylor series. So for example, square root of x, but create that as a polynomial. 1 over x, sine of x, cosine of x, e to the x, ln of x, all those are converted into a polynomial. So that's why we spend so much time on polynomials, because everything is a polynomial or can be converted into a polynomial. The next thing here, let's look at, say, how we write slope. Let's say slope is 2/3. Well, this can also be written as 3, 2 instead of a fraction. Okay, so therefore we can write the equation. So again, taking this piece here, and we can write it, and I'll change the notation and say r of t, my slope, 3, 2, but then we use time, and then we have a plus b. Again, notice this is vertex form yet. Okay, if you want to go to 3-dimensionals, okay, so what does a 3-dimensional look like? Well, it'll be, say, 3, 2, 1, t, and we have a, b, c. Again, still vertex form. Okay. All right. So that's a gamut all the way up through calculus, and that's up to Calc 3 there. But notice it's nothing really too much different than what we started with. So let's come back to some reality here of what we have to teach students in Algebra 1 and Algebra 2. So we have y2 minus y1 equals m x2 minus x1. So therefore, again, we got the equation. Okay. Now from that, we have 2 forms. We have y equals mx plus b, so which implies the slope-intercept form. Again, that's a form. So if we have, let's say, an equation, let's say y equals 2x plus 1, so graphing that out, we have 1, so 2 over 1. So what can we get out of this slope-intercept form? Well, we get 2 things, right? We get the slope, 2 over 1, and we get 1.01. Okay, so 2 things. Now let's look at the other form, standard form. And out of the form of ax plus by equals c. So example, let's say 2x minus, say, 3y equals -6. So how many things can we get out of this form? Well, actually, we can get 3 things out of this. And most people think there's just 2, and that would be the x and y intercept. So If the y was 0, this would be negative 3. If the x is 0, this would be 2. So therefore, the graph of this is 0, 2, negative 3, 0. Now, technically, once we got that value out, we probably could get the third thing with the slope, which would be 2/3. Well, I want to point out, so I already knew what this was, because if you look at another way to represent slope here, I could write this as 3, 2. Well, standard form is also the slope, but it's the perpendicular slope. So the slope here is written as 2, negative 3. Now, one of the things that's taught in geometry is rotating things around by 90 degrees. So they teach them switch the x and y around and change the y value. So therefore, the perpendicular of this, if I switch these two around and change my y value, I would have then 3, 2. And there's my slope. So actually, that's the third thing, is anything you see in standard form. The standard form is the perpendicular to that. And therefore, all you have to do is use what you learn in geometry and then take the next step. So let's go to three-dimensional. Okay. So if you have, let's say, x plus 2y plus 3z equals 4, this is standard form. So my slope is 1, 2, 3. So what does that mean? Well, if you look at the plane of this, it is the perpendicular vector, and that slope is 1, 2, 3. So anytime you hear the word standard form, that's what the slope is. It's perpendicular to that. Now, for example, how would you get, let's say, the 4? Let's say come up here and get the negative 6. Let's do two-dimensional. So basically, let me rewrite this here. We have, say, 2x minus 3y equals negative 6. So the perpendicular vector is 2, negative 3. All we need is a single point on this. So, like, for example, let's take 0, 2. That was one of the points we used to graph. So I just do the dot product of that. So therefore, we have 0 plus negative 6, negative 6. Let's take another point here. Find some room here. Let's say 2, negative 3. Dot that with, let's say, the other point, negative 3, 0. So negative 6 plus 0, negative 6. Let's take something, dot it with another point here. Let's say we have 1, 8/3. So that'd be 2 minus 8, negative 6. And you can keep taking more points. Let's take one more, just for fun. Dot it with, let's say, 5, 16/3. And you have 10 minus 16, negative 6. So notice I just keep getting negative 6. So that's how standard form works. And same thing that works in three-dimensional. All right. So next part. Coming back to writing the equation. So let's say we have the slope of 2 and 4, 2. So the question is, what are some options to write the equation when you're given those two things? I like the word equation. Okay, because that's what you're doing. So I like using y2 minus y1 equals m x2 minus x1, because, if you think about this, there's a little thinking box here, that connection of m equals y2 minus y1 over x2 minus x1. Understanding that these are the same and how things are connected. So therefore, we can go y minus 2 equals 2x minus 4, and you have it. Okay, I do like, yes, a vertex form. It is a form, not an equation, but basically, you're just writing that over. So if you have y equals 2, x minus 4 plus 2, one thing I like about this is that if this is your parent graph of y equals x, and then if you change that parent graph to say y equals x squared, then all you have to do is do 2x minus 4 squared plus 2. Or say y equals absolute value of x. Then it's y equals 2 absolute value of x minus 4 plus 2. But, they do have to simplify that part into one of the other forms. Okay? All right? So, something to think about. Now, before I close here, I do want to point out something here. And if you notice that as I write the equation, it's always y2 minus y1 over x2 minus x1. Some people will say, well, isn't that the same thing as this? And the question to that is yes and no. If you're talking about an equation of a line, you're going in both directions, so it really doesn't matter which way you do it. But if you break this off, then it does matter, because then you have an array. So you either go in this direction or this direction. So this one here is slope without direction. These two here are slope with direction. Okay. So if you look at, let's say if I have a slope of negative 2 over 3, is that the same thing as 2 over negative 3? In all purposes, for algebra 1, yes. But in algebra 2, I start throwing out, if that is true, if you have negative 2 over 3, and we write our slope out of fraction form, you have 3 comma negative 2. Is that the same thing as negative 3, 2? Okay, so if you graph this one out, 1, 2, 3, negative 2, your slope is going this direction. If I graph this one out, 1, 2, 3, up 2, you're going in this direction. So it does matter. But all intents and purposes in algebra 1, like that. But one thing I've seen is, I asked students, I says, how many of you wrote down 2 over negative 3 and lost points in a class? And usually there's quite a few people who says, yeah, I lost points. So I want to point this out, saying, hey, you technically should have left the negative there. But given reasons in terms of, hey, it's actually sometimes better just to leave things like that, because it leads into something like this later on. Okay. So in conclusion here, you have point slope equation. Okay. Again, the key word, the equation. Big fan of that. Now, obviously, if you notice that the vertex form works pretty slick. It really builds into other graphs. So something to think about. One of the other forms I don't think is useful in terms of starting off with it. They do have to know it. So yeah, slope-intercept form. I do believe no matter what you do on these two, they have to be able to go to slope-intercept form. It's very vital on that one. How about standard form? Do they have to go to standard form? I'm more like going the other direction. If you have standard form, can they get it into slope-intercept form? And just to show you a reason why, on the AP exams, a lot of times they'll put it into standard form. And I tell my students, before you even begin to answer the question, put it into slope-intercept form. There's not a single question that they have to have it in standard form. So my calc students just go boom here right off the bat, and then they read the problem. Okay. Other than that, you got some decisions to make. Keep in mind that it does help when students roll in from one class to another class, that the consistency helps so much. When you have people that don't know what this equation is, and I've actually had people, and it's not just one or two, but it's quite a few students each year that have never seen this. So they struggle, and they get very frustrated when they don't even know where this came from. So you guys got some decisions to make, so hopefully put some thought into it.